Hey guys, all right, this is the last example that has to do with Riemann sums for the entirety of the class. So let's talk about it. All right, this actually comes from a quadratic formula and it has to be for ax squared plus bx plus c. In order for us to get through all of those details, it would take a lot of one-on-one time and some explanation. So instead of going through all of that, feel free to look up videos on Simpson's rule, but I'm actually just going to give you the formula itself. You're going to notice that it looks a little different from the trapezoidal rule, but just slightly. A few things. It has a denominator of 3 instead of a denominator of 2. Okay. You can notice that this first term is still by itself. The second term is actually now being preceded by a coefficient of 4. Then it starts alternating back to 2 or to 2, then back to 4. And if you were to keep going, that pattern would continue to alternate over and over until you get to the last term. Once you get to the last term, you just write what the last term is. So it does not necessarily have to be 4, 2, 4, then the last term, or 4, 2, 4, 2, and then it doesn't matter where the pattern leads off. You just have to stick with the pattern on the inside values. Okay, now the example that we're going to work is the exact same problem that we had talked about for example number 1. But this is kind of just doing a comparison between the two. So we're going to go through this the same way, okay? And we're going to calculate it in the same manner, and we're going to get a slightly different answer. And we'll talk about which one is going to be more accurate. This has a lot to do with conic sections, and you would actually get a more exact answer from Simpson's rule. But there are going to be times when the trapezoidal rule will actually give you an even more exact answer. It's going to depend on the shape. So do not be surprised if they say do a side-by-side comparison of trapezoidal and Simpson's rule and determine which one is more accurate or more precise. Okay. All right. So let's go ahead and look at this. If I am utilizing Simpson's rule here, then of course it would be the integral from a to b of, or I guess I should write, well, I'll write out the rule first, of fx dx. And this is equal to b minus a over 3n times, I have my first function. I'm using n equals 4, so that means I'm still going to have 5 terms inside here. This will alternate from 4 f of x subscript 1 to 2 f of x subscript 2 back to 4 f of x subscript 3. That's 4 terms. So now I'm up to my last term, and I just tack on the f of x subscript n. Okay, let's start plugging things in and see what we look like here. This is going to be pi minus 0 over 3 times n. N, according to this problem, is 4. So 3 times 4. Then whenever I start plugging the rest of this in, I'm going to have, okay, f of x subscript 0. There is a little bit of lag here, so I'm going to give it just a second to see if it'll catch up. But you're going to go through the same process that you did with the former one. You know that your first term is going to be kind of f of a, and the last one would be f of b. The values in between are going to be things that you see kind of as you go. Okay. And I'm waiting on this thing to catch up with me. All right, so, and I lost connection. Hang on just a second, guys. Okay, I'm back and everything has now been caught up. All right, so whenever I plug this in, I'm actually going to have the sign of 0 to begin with. And then I'm going to end with the sign of pi. But this goes back to where you still have the same thing. You're adding b minus a over n. Pi minus 0 over 4 means I'm adding intervals of pi over 4 to each term. So this becomes plus 4 times the sine of pi over 4. Plus 2 times the sine of pi over 2, plus 4 times the sine of 3 pi over 4, plus the sine of pi. Then when I start simplifying, this gives me pi over 12 times 0 plus 4 times radical 2 over 2, plus 2 times 1, plus 4 times radical 2 over 2, plus 0. When I clean this up a little bit, I'm going to go ahead and move it over to the next page. I have pi over 12. The 0 can just go away. I do have 4 times square root of 2 over 2, and you can definitely simplify that. Give me just a second to get everything else written down, and then I will do just that. Okay, I can cancel. 2 will go into 4 2 times. Same is true here. So I actually have a 2 radical 2. In both of these, I have my plus 2 in the center, all being multiplied by pi over 12. Of course, I can simplify that to get pi over 6, but I am also going to add these two terms together, which is 4 radical 2 plus 2. All of this multiplied by pi over 12. Okay, so if I factor out a 2, that's going to cancel or reduce to give me pi over 6 times 2 radical 2 plus 1. And you can leave it just like that. Now, to give you some insight on exactly what's happening here, not that you're incredibly concerned with it, but if you were to convert this to a decimal for comparison purposes, Simpson's rule would actually give you 2.005 approximately, okay? The trapezoidal rule from this exact same thing is going to give you approximately 1.896. Now, I know all of you are asking the question, so which one's closer? I'm so glad you asked. Let's take a second and actually apply the fundamental theorem of calculus here, from 0 to pi of sine x dx. If I take the integral of sine x, it's got to catch back up. Okay, if I take the integral of sine x, that's actually going to be negative cosine x, and I'm going to evaluate this from 0 to pi. So that would be negative cosine of pi minus negative cosine of 0. Hang on just a second. My face is in the way, so I'm going to fix that problem. Okay, well, when I simplify this, cosine of pi, if you think back to your cosine curve, okay, here's where pi falls, is going to be a negative 1. So this is minus a negative 1. Minus a negative in cosine of 0 is 1. Well, negative 1 is a positive 1, and a negative 1 is a positive 1. So this gives me an exact value of 2, which means for this problem specifically, Simpson's rule is actually the better approximation, even though it is slightly overdone. So if you guys have any more questions, or if you want to know exactly what the Simpson's rule is representing as far as a geometric thing is concerned, I'll definitely be posting some links and stuff, so that way you guys can have access to that. Have a good evening.